In this video, I'm gonna show how to find the determinant of matrix in different sizes. A few things to know about determinant is that it only applies to square matrices, and therefore if you have a 3x4 matrix, you cannot find its determinant. So over here, I have two ways to denote the determinant. The first one is by using the abbreviation DET, and then in parentheses you have the letter A, or any letter you use to represent the determinant. The other one is using the absolute value symbol, but in this case, it does not mean the absolute value. Instead, it means the determinant of that matrix. It's very important that we know how to find the determinant because it's very useful for solving systems of linear equations, especially when you have a lot of variables, and you can do that by using the Cramer's rule. So the first one is how to find the determinant of a 2x2 matrix. Suppose I have a matrix over here denoted by whose entries are A, B, C, and D. You simply multiply the diagonals, and then you subtract the you find the difference. So in this case, its determinant is AD minus BC. So it's very important that you do not switch the position of these two, because otherwise you will end up getting a different answer. So over here I have an example. So this matrix, I have the entries 7, 2, 3, and 5. Suppose I need to find the determinant. I need to multiply 7 and 5 and 2 and 3. And I need to subtract these two. So 35 minus 6, I have 29. So it's very important that you actually you do not switch the order of these two. For a 3x3 matrix, so suppose I have a 3x3 matrix over here, and then if you need to find the determinant, you have to copy the first two columns over to the side, and then you need to find. It's very important that you actually write out those entries, because it shows you what entries you need to multiply. So basically you will find the product of each diagonal that points in the same direction. So in this case, for the diagonals that are slanted to the right, I will find the product of each of these diagonal, and then I will add them together, so as I shown over here. And for the diagonals that are slanted to the left, I will also do the same thing. I will find the product of each of these diagonals, and then I will add them together. So finally, the last step is I will subtract the sum of the products of each of the diagonals pointing to the left from the sum of the diagonals of the products pointing to the right, as shown in the color green. Down here I have an example. So if I need to find the determinant of this 3x3 matrix, first I copy the first two columns over to the side, and then I find the product of each of these three diagonals, and then I add them together as shown over here. And then for the same thing, for the diagonals that are pointing to the left, I would do the same thing. I find the product of each of these three diagonals, and then I add them together as I have over here, and then I will subtract these two. So two things. The first one is you actually write down these entries so that it's easier to tell what entries you need to multiply. The second thing is you do not switch these two positions, because otherwise you will get a different answer. So now, to find the determinant of any matrix, you need to multiply each entry in any row or column of the determinant by its cofactor, and then you add the results. So over here I have an example. So suppose I have this 4x4 matrix. So the first step is to pick any row or column. In this case, I picked the first row. And after that, I have to find the minor in for each entry in this row that I picked. So the way you do it is that I will circle the A in the 1, 1 position, and then I will cross out the column and the row in which this entry is located. So in this case, I'm going to cross out this row and this column, and then I rewrite the matrix over here, and then I find the determinant using the procedure that I talked about for a 3x3 matrix. And then I keep doing the same thing. For the entry in the 1, 2 position, I will circle this entry, and then I will cross out the row and the column in which this entry is located. And then I write the new matrix over here, and then I will find its determinant. And so I keep doing the same. You would do the same thing for all the entries in the row in which you pick. And then after that, you need to multiply this entry by its cofactor. So I'm gonna explain what cofactor is later. So first of all, suppose we let the minors in the 1, 1 position be x, and the 1, 2 position be y, 1, 3 position be z, and in the 1, 4 position be k. So the cofactor is basically the number -1 raised to a power depending on the position of the entry, and then multiplied by its minor. So for the entry A, we know that it's in the 1, 1 position. So therefore, we take -1, we raise that to the 1 plus 1 power. And then since the minor corresponding to the position 1, 1 is x, I will multiply this by x. And for the entry B, we know that it's located in the 1, 2 position. Therefore, I'm going to raise -1 to the 1 plus 2 power. And then since we know that its minor, the corresponding minor to this position is y, I'm going to multiply y to -1 raised to the 1 plus 2 power, and then b. So I would do the same thing for C and D. So for C, its position is 1, 3. So I would need to raise -1 to the 1 plus 3 power. And then its corresponding minor is Z. Therefore, I also need to multiply Z. And then I will do the same thing for D. So finally, to find the determinant, I just need to multiply all of these together. So I have an example of this. Suppose I have this 4x4 matrix over here, and if I want to find the determinant, first of all, the first step is to pick any row or column. So as you can see, in this case, I picked this column over here. The second step is to find the minor of each entry in the row or column chosen. So since I chose this column over here, I will need to find the minor for each of these entries. So to find the minor for the entry 1, 1, I will circle the 0, and then I'm gonna cross out the row and the column in which 0 is located, and then I write the new matrix over here. I find the determinant of this matrix, and over here is I actually did it by hand. It's just to show. It is just to remind how to do to find the determinant of a 3x3 matrix. So I find the product of each of these diagonals, and then I add them together, and then I also find the products of each of these diagonals pointing to the left, and I add them together, and then finally I subtract the 2. I get -2. So basically, I would do the same thing for the position 2, 1, 3, 1, and 4, 1, and these are the determinants that I get. And step 3 is to find the cofactor. So the cofactor is basically -1 raised to a power depending on the position of the entry, and multiply that by the minor. So to find the cofactor for 1, 1 for the entry in the 1, 1 position, so I would take -1 raised to the 1 plus 1 power, and then I'm gonna multiply that by -2. The reason why I multiplied that by -2 is because we know from here that the minor for the 1, 1 position is -2. So I would do the same thing for the entries 2, 1, 3, 1, and 4, 1, and these are the cofactors for these entries. And the last step is to multiply the cofactor by its corresponding entry, and you add them together. So we know that in the 1, 1 position, its cofactor is -2, and the entry in the 1, 1 position is 0. So I multiply 0 by -2. And then for this one, we know that the cofactor for the 2, 1 position is 0, which as I have over here. And then since the entry in the 2, 1 position is 2, I will multiply 2 and 0, and then I do the same thing for the entries in the 3, 1 and 4, 1 position, and I add all of these together. I get that the determinant is 2. And just to show you guys, it does not really matter which column or row you choose, because either way you will get the same answer. So over here I have the same matrix that I showed you before, and here instead of picking the first column, I decided to pick the second row. And I basically follow the same procedure. First, I find the determinant of each of these entries, and then I find their cofactors, and finally I add each cofactor to the entry. And as you can see that I also have 2 as the answer. So it shows that it does not matter which row or entry you pick. Either way, you will get the same answer in the end. And the last thing I want to show you guys is you can actually verify this on a calculator. So the way you do this is, first of all, you hit second, and then you hit matrix, and then you go to the right, you go to edit, and then I click on 1. So in this case, it's a 4x4 matrix. So on the top, I'm gonna type in 4x4, and then simply you just enter each entry. So over here I have 0, 1, 1, 0, 2, 0, 0, 1, and then 0, 0, 2, 1, and 1, 1, 1, 0. And then I go back to the home screen. Then I click on second matrix. I go to math. I click on the first one because as I talked about before, DET, it's basically the determinant. So I clicked on 1, and then I go to second matrix, and I call out the matrix. I store that in 1, so I'm gonna type in 1, and then this calls out the matrix that I just entered, and when I hit enter, it shows you the determinant, which is 2. So there are 2 ways to verify that you have the right answer. The first one is it's more I guess more work, because you can decide to pick a different row or column just to verify that you get the same answer in the end. The second one is a lot easier. You just type it into the calculator.